All right, everybody. So I want to make sure that everyone is kind of on the same page for doing these mass-to-mass stoichiometry problems. So I wanted to kind of make a sample video that showed you how to do a couple examples and also kind of explain what the process is for doing mass-to-mass stoichiometry. So anytime you're doing mass-to-mass, that means essentially we're going from grams of, let's say, A, and figuring out how many grams of, let's say, C that would be equal to. So in a mass-to-mass problem, what we are trying to do is convert from grams to a different type of grams. So we're essentially figuring out how much product are we going to make. So if you read over the problem that I've written for you, we're given a couple things. If you have 5 grams of A, so we're given 5 grams of A, how many grams of C will we produce? So essentially, we're trying to figure out, if we're starting with 5 grams of A, how much product will we produce? So the way you set that up is always kind of in 3 set steps. You take what you're given and you put that over 1, always. So that's always step 1. Okay? Step 2 is where you are going to convert grams of A into moles of A. And it's always 1 mole of A and however many grams that is. And we call that number the molar mass. So this will be different for every chemical that we have. It just depends on what it is we're looking at. So if we were looking at the molar mass of water, that would be the weight of hydrogen plus oxygen. So in this case, I'm going to leave that blank because we don't know what A is. This is just simply an example, but we will see an example in the upcoming slides. So once we get to that point, our step 3 is to go into a mole ratio, where we are converting moles of A into moles of C, which is essentially what we have, which is A, into what we want, which is C. And we're going to get these numbers directly from our balanced equation here. So we are literally going to take this 2, and that's going to go here. And we'll take the 3 and put it there. Okay? So these numbers are totally dependent on your balanced equation. If you don't have your equation balanced, you won't know what this number and this number should be. But they simply come from this balanced equation here. So once we've done that step 3, which is the ratio, our last and final step, which is step 4, is to go from moles into grams. Okay? So before in step 2, where we went from grams to moles, now we are going from moles of C into grams of C, which again will be totally dependent on the molar mass of whatever it is we are trying to find. And it's always 1 mole. So whenever you have a molar mass, so if we're ever looking at a molar mass problem, like this one, oh no, that was not supposed to be that dark, hold on. Like this guy here, or this guy here. Those are both molar mass steps. We always make that 1 mole, okay? It's always the weight of 1 mole. So if I said, hey, so-and-so, I need 1 mole of carbon, you would go into the lab and you would weigh 12 grams of carbon, because that is the molar mass. That is how much mass 1 mole of carbon has, okay? So once we do all those steps, we'll go through and we'll check our units to see what crosses out. Grams of A will cross out, moles of A will cross out, moles of C will cross out. The unit I'm left with is grams of C, and that is precisely what I was asked to find in the problem. So when you are going through these steps, you should be able to effectively cross out all of these units with the exception of 1, and that is your answer. So if that doesn't happen and you go through and your units aren't crossing out, that means something was set up wrong. So you should go back and try to figure that out. So let's take a look at an actual problem here. Okay, so in this problem, we are trying to start lithium hydroxide and react that with bromic acid to form lithium bromide and water. So it's telling us in this problem that we are starting with 10 grams, oh gosh, I did not want that to be the highlighter tool, 10 grams of lithium hydroxide, which is that guy there. And it's asking how many grams of lithium bromide, which is, do this in another color, how many grams of lithium bromide will be produced. Okay, so that's what we're trying to figure out. We're trying to figure out essentially, if I have 10 grams of lithium hydroxide, how much product am I going to form? So the first step in that is to start with what we're given. So that's always step 1. And that's to put 10 grams of lithium hydroxide over 1. Now the next step is going to be going from grams of lithium hydroxide into moles of lithium hydroxide. And remember, this number that goes with moles is always 1. It's always for 1 mole. So if you add up the weight of lithium, oxygen, and hydrogen, the molar mass of that, of 1 mole of lithium hydroxide, it will weigh 23.9 grams. Okay, so that is the molar mass of lithium hydroxide. So that is our step 2, which is to go from grams to moles. Okay, so that's our step 2. Our third step is to use the mole ratio, which is where we're going from moles of lithium hydroxide into moles of what we want, which is lithium bromide. Okay, and we're going to get that from just looking at the balanced equation, and all of these are just 1s as their coefficient. So this is just a 1-to-1 ratio. And our last step, which is step 4, is going to be going from moles back into grams. So I'm kind of running out of room here, but we'll want to put moles of lithium bromide, 1 mole of that, and whatever that weight is. So let me add up here lithium and bromine. And the weight of that, if we add up the lithium and the bromine, 1 mole of lithium bromide will weigh 86.8 grams in 1 mole, okay? So what we end up getting now, if we scroll this down and I put a nice big equal sign down here, if we look through what crosses out, grams of lithium hydroxide will cross out, moles of lithium hydroxide will cross out, moles of lithium bromide will cross out, and the unit I'm left with is grams of lithium bromide, okay? And that is precisely what they asked me to solve for. So now I'm just going to go through and solve this for what the answer should be. So I'll take, let's see, let me get my calculator pulled up here on my phone. We will take 10, divide that by 23.9, and multiply that by 86. Ooh, I got that all messed up on my calculator. Hold on, give me 1 second. You're probably way ahead of me. And the answer I get is 36.3 grams. So let me just double check that I did my math right before anyone gets confused and like, why did she type that? Just to make sure. It's always good to double check your math, and that is the correct answer. So if I were to take 10 grams of lithium hydroxide and put it through this reaction here, I would make precisely 36.3 grams of lithium bromide. And that is stoichiometry. That is where you're trying to go from grams of what you're given and figure out how much product it is you're going to make. Okay? So let's try one more problem together. Okay, so now we're going to start with a different one. In this problem, we are given that we are starting with 45 grams of ethylene, which is C2H4, and we're trying to figure out how many grams of carbon dioxide will be produced. So I think we may have gone through a problem very similar to this, except now this is going to be another grams of one thing into grams of another thing. And if you notice, this equation is already balanced for us. So this would be a 1 coefficient, 3, 2, and 2. Okay, so it's already nice and balanced. That won't always happen, so please expect to start seeing things that you will need to balance. But for this case, just to keep it simple, we're going to do that. So we're always starting our step 1 with taking what we are given and put that over 1. Okay? Step 2 is always going to be, now try to remember it before I say it, grams to mole. So we are trying to convert grams of ethylene into moles of ethylene. Oops, C2H4. This number is always 1 here. Always, it will always be the weight of 1 mole. And if I add up the weight of 2 carbons and 4 oxygens, that's 24 plus 4 is 28. So the weight of ethylene is 28 grams in 1 mole. Our next step, which is step 3, is to go from moles to moles. We call this the mole ratio. So this is going to be going from moles of ethylene into moles of CO2, which is what I'm interested in getting, carbon dioxide, okay? So if I go up to this problem here, I'm looking at the coefficient that goes with acetylene and the one that goes with carbon dioxide. In this case, 1 mole of acetylene will produce 2 moles of carbon dioxide. And finally, our step 4 is going to be going from moles back to grams, okay? And that's where we will have moles of CO2 and whatever the molar mass is of that, which is grams of CO2 on top. So how much 1 mole weighs. So that's 12 plus 16 plus 16 is equal to 44. So carbon dioxide weighs 44 grams in 1 mole. Now before we go through and do the math for this, I just want to double check and make sure all my units cross out, and the thing that I'm left with is that unit that I want, which is grams of carbon dioxide. So grams of ethylene cross out, moles of ethylene cross out, moles of carbon dioxide cross out, and the thing that I'm left with is grams of carbon dioxide. Hot dog, that's what I wanted. So that means I set everything up right. I am good to go and solve. So in my calculator, I'm going to take 45 divided by 28, multiply that by 2, and multiply that by 44. So if I were to go through and I take 45 grams of ethylene and I run it through this combustion reaction right here, I will produce exactly 141.4 grams of CO2. And that is my answer, okay? So I hope that helps. If you need any further help with this and you're not quite sure how to set it up, one of the things I really strongly advise students do that a lot of students don't do is do this step here where you're kind of making sure you're adding in all these units, because it really makes it visually easier for you to see. And it makes it easy for you to see what it is that you're crossing out and what you're going from and what you're turning it into, because essentially we're just using math to figure out how much product we're going to make. And all these numbers are just coming from either the periodic table in the case of a molar mass or this balanced equation here for the mole ratio step, okay? So always follow these steps here. If it helps you, memorize this step process where we're going from grams to moles, moles to moles, moles to grams. It's only 6 things you have to remember. If you can remember that and set it up properly, you're kind of foolproof. I mean, it's pretty easy to do these problems once you get the hang of it. But let me know if you have any questions. I'll be happy to help you. But I hope this video does help.